We already have a first question in the chat. Andre, can you unmute and ask the question yourself?
Hey, can you hear me?
Yeah.
Hello, my name is Andre. So it was the question around slide 11, I think. My question is like, for parallel region, as I understand, like each something flowing into the parallel region has to have an data attribute, whether it's explicitly specified through the OMP clause or through implicit default rules. And the question was, why don't we have this implicitly used data sharing attribute represented explicitly in the MLIR representation? Or is my understanding completely wrong?
So this just shows a in trivial OpenMP parallel operation. So there can be shared clauses which will say which are the clauses that have to be shared, and then we will lower it accordingly. So this was just a trivial operation. So I'm not saying that these are all shared by default, but this was just a trivial example. So if you see later in the slide, at least somewhere, I hope there will be, you can see there is an operation, parallel operation with a shared clause here that can say what are the variables that are shared. So, yeah, so
I will kind of rephrase my question. If I have like memory F that is live into the region,
right,
I would expect that it must have some data sharing attribute, whether explicit or implicit. Is it correct?
Yeah, okay. You're saying that if there is a live in, yeah. So I would throw that question to Johannes. So Johannes, what is the default handling of live-ins in the IR builder?
That is, it's not for the IR builder to decide, but yes, every live-in will have a default, like an implicit or explicit data sharing attribute, and yes, but the ones are not made explicit by Flang at this point. That is correct.
So my question, like, would that be like every live-in be explicit in the MLIR level representation? I understand why we need implicit on the front-end level in AST, but once we lower into the middle end, would you expect that everything will be explicit, or will we still have like these implicit rules?
So that will be a transformation. So what I intend is that it will be a transformation. Whatever the user specifies will be there in the initial representation, but there will be later a transformation which will make it canonical and have shared or private for all the attribute or for all the live-ins and variables.
Yeah, it might make sense to make it explicit because at some point you'll have to decide what it is anyway, like what kind of sharing is applied. So it might make sense to make it explicit, especially once we start to perform transformations or analysis on the MLIR level.
Right.
But there has not been any effort to do so yet.
Okay, thank you.
Okay, we have more questions here. The next one is a quick one. Can we make the slides available?
Yeah, sure.
Okay.
I can hand it over to Johannes, who can distribute it or make it available on the website.
That will be great. And Colleen, you want to ask the question yourself?
Sure. Yeah, so this is quick, hopefully. So at the start of the talk, you said that LLVM-IR is too low level for Fortran to initially be lowered into. So could you give like from a high level perspective, a little bit more detail why? Like, is there something in particular in Fortran features that makes this not able to optimize well or something?
So I think it has to do with a lot of arrays are there. So there are various kinds of arrays. The default sharing rules are different for Fortran and C, C++. So so I'm not an expert in this FIR layer. I'm more interested in working OpenMP MLIR. But from what I've understood is that there are various kinds of arrays, and by the time you reach the LLVM-IR, you have lost the original array and the loop information. So you have to basically reconstruct all these to do the optimization. Whereas in the MLIR layer, you have loops as well as the array information fully intact. So using that, you can easily do optimizations like vectorization and all that.
Okay, yeah, thanks. That makes sense. So yeah, arrays have different properties in Fortran. So thank you.
Okay, we have another short question here. Joey, you want to read it yourself, or should I?
Oh yeah, just very quickly. How long would you estimate the new Fortran project will be robust enough for production? Thanks.
So timelines for the project has been difficult to promise, because these are software projects which always take more time than you intend. But it should be in some stage ready by end of next year. Whether it will be able to completely replace the existing compilers, I don't know, but I think it should be available in some form for people to use from end of next year.
Okay. And let's say you have a question as well?
Yep. So my question is, one of the reasons behind MLIR is progress in lowering and the optimization opportunities that come with it. Have you already explored any optimization from the MLIR side, like at the high level?
There is no implementation there as of now, which does this optimization. That will come as we make progress. But some of the suggested ones include, like there are a lot of loop optimizations available in MLIR, like if you have the collapse construct which collapses loops. So these are optimizations that can be easily done in MLIR. So our plan is to get it into a state where people can experiment and see what is better, whether it's best to do it in MLIR or whether it is best to leave it to LLVM to do all this optimization. The other important one is to moving constants into regions. So these are already implemented in other dialects. So there exists code in MLIR which can do this constant propagation into regions. So these are some of the things that we would try to do.
Another follow-up question is: Do you intend C to also move in this direction of MLIR? Do you think that OpenMP should be placed in MLIR as well?
Sorry, could you repeat that question?
Yeah, sure. Do you think that the whole OpenMP infrastructure should be moved to MLIR? Like, would you argue that the future of OpenMP in LLVM should be moving to MLIR?
Having worked in MLIR, so yeah, that would be my recommendation. But obviously, there are a lot of practical difficulties because the Clang compiler does not use MLIR. So that makes this difficult. But the hope is that once Clang starts using MLIR, then there is this MLIR dialect already in place. So yeah, hopefully in the future, once Clang also starts using MLIR, all the OpenMP handling will be in the MLIR layer.
Thank you.
Matt, you want to ask a question?
Sure. Great talk, by the way. So I'm curious about one aspect. How do you handle debug information? And the particular aspect I'm curious about is whether you have observed any benefits of MLIRs source location tracking for debugging info preservation in optimized code, which is a common issue in Flang.
Yeah, I mean, I'm not familiar with the location tracking or the debug information that is provided by MLIR, and I don't have much experience that I can give you a confident opinion about. Until some months back, there was no debug information that was generated for the LLVM layer, but I think it was recently added. So there is some information out there. How good it is, I don't know.
But to be fair, the optimization which lose the debug information that Flang produces are inside LLVM core, and those are the same ones that will run for Flang as well. So the optimizations that lose debug information are run for both. Regardless, because Flang also introduces very nice and good debug information into the IR, we just lose them on the way. That's the problem here. I think Brian is cutting out. The question, I can read out the question. So it says, is the AST lowered into one MLIR representation or two to be separately processed via OpenMP dialog conversion and LLVM-IR dialog conversion? How are the results for the two conversions to MLIR representations?
So, Johannes, you broke up a bit there. So I don't know. I think is the question that having these OpenMP MLIR representation sitting along with the MLIR representation, whereas the other approach is to convert the OpenMP MLIR also into LLVM MLIR. Is that the two things that are being compared here?
Yeah, I think one aspect is it looks like the MLIR lowering creates two separate things, and they look kind of completely separate, like separate pipelines that are handled separately. But the point is, it is one module. It is like the FIR and the OpenMP MLIR dialog are interleaved, so it's not like separate. It's just for the sake of the representation separate here. It's actually all mixed together, all scrambled together.
Yeah.
Very good. Father, you want to ask the last question for this talk?
I don't have a question. I just wanted to share a link about why we don't lower to LLVM directly.
Oh, okay. This is okay. Very good. Perfect. In that case, we're right on time, if I'm not mistaken, which is perfect. Or a little late, but that's okay. Thank you very much. It was a great talk. We had a lot of good questions, and we will have a 5-minute break before we go into our third talk for the day, after which we have a half-an-hour break. So bear with us for a little bit longer, and then you can walk around or do other things. Okay, see you in 5 minutes.
Okay, thanks everyone.